Okay, start. So, hello everyone, good evening. We are going to discuss the session 5 on probability and statistics. Previously, we have discussed 4 sessions: linear algebra, matrices, numerical methods, and probability statistics. Now, the second session on probability statistics. In previously, that is probability statistics, we had discussed basics, addition theorem of probability, conditional probability, that is dependent events, and multiplication theorem. Okay. Now in this session, I am going to give the lecture or discuss on independent events, Bayes theorem, rule of total probability, etc. Okay. Independent events. Previously, we had dependent events. That is, after the occurrence of event B, then an event A happened where A depends on B. So we found in the previous one P of A by B, P of B by A, etc. Okay. Now coming to independent events, two events are said to be independent if the occurrence or non-occurrence. Occurrence means event happened. Non-occurrence means event doesn't happen. Non-occurrence of one event is not affected. Here typing error, EFFE. EFFE, ECTED. Affected by the occurrence or non-occurrence of the event A. That means, suppose A is an event which is not affected by an event B or B dash, then A and B are simply called independent events. Okay, result. If A and B are independent events, then this is conditional event in the previous session. P of A by B. What does it mean? Event A depends on event B. But here it is mentioned independent. So there is no use of this fractional event A by B. For what is the meaning of P of A by B? We are finding probability for event A after B happened. But here A is independent on B. So this is nothing but probability of A. Similarly, probability of B given A is nothing but probability of B. Now, previous class, what is P of A intersection B? Probability that both the events A and B occur. That is given in the previous session, that is conditional events multiplication theorem. If probability of event A happened multiplied with probability of the next event B happened, given that A already happened. That is P of A into P of B by A or P of B into P of A by B. But just now in the first condition, P of A by B is equal to P of A, P of B by A is equal to P of B. So that is why in the case of independent events, probability of the events A and B, that is both occur. Both occur. Is nothing but product of the probabilities. This is called multiplication theorem for independent events. Number 3. When A and B are independent, A comma B dash, A dash comma B dash, and A dash comma B are also independent. Okay. So because of occurrence or non-occurrence of one event is not affected by the occurrence or non-occurrence of other event. Okay. So based on this, I will go to one example. Solution. A bag contains 10 blue marbles, 20 green marbles, 30 red marbles, total 60 marbles. A marble is drawn from the bag, color is recorded, and is put back in the bag. That means once a marble is drawn, after recording the color, after knowing the color, then back into the bag. So there is no total change of the balls or marbles for every time picking. This process is repeated 3 times. That is 3 balls drawn one by one with replacement. Put back in the bag means with replacement. So when there is a condition back into the bag or with replacement, such a problems, immediately you identify independent events. Okay, a student, suppose a problem is given, going to solve 3 students. Each student solving with respect to a probability given. The problem is solved means at least one of the students is solved, then the problem will be solved. Such problem is a simple example of independent events. Now, a target is there. Some person hitting the targets, A, B, C, 3 persons hitting the target with probabilities, etc. Such an example is also independent event. Simply saying that when there is a condition with replacement, such example, such problem is called independent. If it is without replacement, such problems are called dependent events, that is conditional probability. So the probability that to no 2 of the marbles, underline, no 2 of the marbles have the same color. That means no 2 marbles have the same color means all the marbles are of different colors. Okay, so total marbles is 10 blue, B stands for blue, plus 20 green, G stands for green, plus 30, R stands for red, is equal to 60 marbles. So every time one marble is picking and put back into the bag after seeing the color. Okay, so no 2 of the 3 marbles. Why I am writing 3 marbles? This process is repeated 3 times. 3 marbles drawn one after one with replacement. Drawn, have the same color, implies all 3 marbles drawn one after one with replacement are of different colors. Therefore, required probability is 3 factorial 6 ways into each way is 1 blue marble out of 60 marbles. 1 marble can be drawn in 60 C1 ways. That first marble, say blue marble, 1 blue marble can be drawn from 10 blue marbles in 10 C1 ways because it is replaced. So there is no change in the total marbles. Again 60 C1. The second marble is green. There are 20 green marbles. 1 green marble can be drawn in 20 C1 ways. Again put back into the bag. There is no change in the bag, the total balls before picking the third time. So 60 C1. And the third one is red ball. From 30 red balls can be drawn in 30 C1 ways. Why it is 3 factorial? That is, this is 6 possible ways. Here, it is not mentioned first is red, second is blue, or third is green, or first is green, third is red, like that. So that 6 possible ways, that is, see, red, blue, green, blue, red, green, blue, green, red, red, blue, green, red, green, blue, green, red, blue, green, blue, red. These are the 6 ways. Each way is this is the each way answer. 10C1 by 60C1 into 27 by 67 into 37 by 67. Here permutations takes place 3 factorial ways because the position of the ball is not given. So that is why 6 ways. If the question asks first is blue marble, second is green marble, third is red marble, then it should not multiply by 3 factorial ways. So 6 into 10 by 60, 1 by 6, 20 by 60, 2 by 6, 30 by 60, 3 by 6. So 2 into 3, 1, 6 cancelled, again 1, 6 cancelled, 1 by 6. Accordingly, the answer, that is the option is B. So here, the balls drawn 1 by 1 is independently because back into the bag. Put back in the bag means independent events. Now, Bayes theorem. This is called generalized of conditional probability. Bayes theorem is also called, I am writing here, generalized conditional probability. Now, what is conditional probability? P of A given B. That is probability for finding the event A given that B has happened. That is P of A by B means probability for event A after the occurrence of event B. Similarly, what is P of B by A? Probability for the event B after the occurrence of event A. Now, here, there are initially n events, E1, E2, so on, En. Are n mutually exclusive and exhaustive events? In the last class, I told you mutually exclusive means events cannot occur simultaneously. All the events doesn't happen simultaneously. Exhaustive events means total possible outcomes are distributed to E1, E2, so on, En. Maybe equally or partially. That is the total sample space S outcomes is divided into the n events, E1, E2, so on, En of a random experiment. And this second step event is very, very tough case. A is another event associated with or caused by. That means in the initial first step events, from these events, it was caused. A is an event caused by the basic events E1, E2, so on, En. That means A depends on E1, similarly E2, so on, En. Then the conditional probability underlying of EI given A. That means we are finding the probability for event EI after the occurrence of event A. Okay. So already you told sir, A is caused by E1, E2, so on, En. That means A depends on E1, similarly E2, so on, En. But here you are finding probability of E1 or EI given A. This is called inverse event probability. Very, very important. Bayes theorem application means finding the probability for inverse event. What exactly inverse event? Some mathematical definitions without example is difficult to understand. After doing one example, you will well understand this Bayes theorem. What is inverse event probability? So, P of EI given A is, this is the symbolic notation, P of EI by A is equal to probability of numerator event EI into probability of A given EI. A given EI is the inverse of EI given A. That is called inverse event. Whole divided by all total cases in denominator. What is all total cases? In numerator, only one of the E1, E2, En. But in denominator, all total. That is total denominator is a sample space. Probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2, so on, probability of En into probability of A given En is called Bayes theorem. And only denominator in this Bayes theorem, which is denoted by probability of event A, is called theorem of total probability or rule of total probability. So you will understand well after doing one example. Some mathematical definitions are very tough to understand without example. This one. This is a gate question. I think 2005. A box contains 3 blue balls and 4 red balls. Another, 3 blue, underline, 4 red. Another identical box containing 2 blue and 5 red. One ball is picked at random. This is arbitrary event. So, without selecting the box, can we pick a ball? So, here the first type event, selecting the box and then picking a ball. Which ball? It is found to be red. Okay, from one of the 2 boxes, one ball is selected. The probability that it came. So, came means inverse event from the first box. So, here, let E1, comma, E2 be 2 events denote that selecting first box, comma, second box, respectively. RESP means respectively. Then there are 2 boxes. One box is selected in how many ways? There are 2 boxes, that is total 2 boxes. Either of the box is selected in 1 by 2 is equal to probability of E2. Now, what is the arbitrary event? Picking a ball found is, and it is found to be red. Let A be an event that picking a red ball or picked a red ball. So, red ball is belong to either box 1 or box 2. Here it is not mentioned. Then, please observe the middle steps, intermediate steps are important. P of A given E1. What does it mean? Here, probability of event A after the occurrence of event E1. That means after selecting the first box, then pick a red ball. So, go to the first box, total balls 7. One ball you are picking 7C1 ways. Which ball we are picking? Red ball. There are 4 red balls. One red ball can be drawn in 4C1 ways. So, probability of a red ball after the selecting the first box is nothing but 4C1 by 7C1 ways. That is 4 by 7. And P of A given E2. What does it mean? A given E2. After selecting the box 2, pick a red ball, then find the probability. That means probability of picking a red ball from the box 2. In the box 2, total balls 2 plus 5, 7. There are 5 red balls. One red ball can be drawn in 5C1 ways. Out of total 7 balls, one ball can be drawn in 7C1 ways. That is 5 by 7. Since total balls in each box is 7. Now required probability. Required probability is the probability that it came. It came is here right now event A has happened. It is asking probability from the first box. First box we denoted by event E1. So what is this? Is inverse event. E1 by A is the inverse event of A by E1. That is a special interest in Bayes theorem. So now it is asking from box 1 after the picking of red ball. According to Bayes theorem, how to remember the right side? Probability of numerator of this fractional event into probability of its inverse event, that is A given E1. In numerator, any one of these E1, E2, so on, En. But in the denominator, total cases. That is called rule of total probability. That is probability of E1 into probability of A given E1. Sometimes I am writing slash, sometimes original division. Both are same. Plus probability of E2 into probability of A given E2. Using base 0. Now, coming to this, probability of E1 is 1 by 2 into A given E1, 4 by 7, whole divided by 1 by 2 into 4 by 7. Probability of E2 is 1 by 2. Probability of A given E2 is 5 by 7. All 2 sevens cancel. Numerator is 4. Denominator is 4 plus 5, 9. So answer accordingly option B. We'll see one more example. Yes, very, very important. This is also GATE question. In a given day, in the rainy season, it may rain 70% of the time. If it rains, chance that a village fair will make a loss on that day is 80%. Because in rainy season, generally more rains, so loss on village fair, okay, chances are more, 80%. However, if it doesn't rain, okay, there is no rain in that day, in the rainy season, on a particular day, the chance that the fair will make a loss on that day is only 10%. Naturally true. If there is no rain, there will be less loss, 10%. If the fair has not made a loss on a given day in the rainy season, so here event happened, given means already happened. So there is no loss on a given day in the rainy season. What is the probability that it has not rained? That means in non-rainy day, we are asking the probability after the occurrence of no loss on a given day in the rainy season. Okay. So this is also inverse event probability based. Solution. Let E1, comma E2 be two events denote that the given day or a given day is rained comma not rained respectively. Then probability of even E1. So rained is 70%. So 7 by 10 or 0.7. Probability of E2 automatically 1 minus 70% or 100% minus 70%. 100% means 1. 30% means 3 by 10. Now, the second type event is important. That is arbitrary event. Let A be an event that means denote. The question relate to fair has not made a loss. That no loss, single inverted commas, on a given day in rainy season, not required to write. I hope that you understand. Everyone following? Then P of A given E1. What does it mean? If it is rained, then the village fair has no loss on the rain day. How much? See here. If it doesn't rain, if it rains, the chance that a village fair will make a loss. But here it is asking no loss. If there is a loss in the rain day, 80%. So no loss means 100% minus 80%. 100% means 1%. 1. So this is 20%. That means 2 by 10. Similarly, P of A given E2. What is the meaning of A given E2? If it is not rained a given day, the probability that the village has no loss. However, if it doesn't rain means no rain. Village loss is 10%, but the question related to no loss. So 1 minus 10%, that is 100% minus 10%, 90%. 90% means 9 by 10. Now what is the required probability? This event A is already now happened. It is asking that day is not rain day. Not rain day is denoted by event E2. Therefore, required probability is probability of E2 given A. So, if there is no loss on a given day, that given day, probability that the given day is not rain day. That is the meaning. Using Bayes' theorem, probability of numerator event E2 into probability of inverse event E2 by A, inverse is A by E2, whole divided by denominator all total cases, probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Since using Bayes' theorem, so what is probability of E2? 3 by 10 into probability of A given E2, 9 by 10, whole divided by probability of E1, 7 by 10, probability of A given E1, 2 by 10, plus 3 by 10 into 9 by 10. So 3 into 9, 27, all 10s cancel, 72, 14, 3 into 9, 27. So this is 27 by 41. Accordingly, the option is D is the answer. So let us look at another example. A screening test is carried to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Underline incorrect. Assuming that the probability of a person getting a positive report is 0.01. Automatically getting a negative report is 1 minus 0.01 is 0.99. Okay. Comma, the probability that a person tested gets an incorrect report. So finally, we are finding probability of which event? An incorrect report. Okay. So solution. Let E1, simple working, denote, arrow means denote, positive report, and E2 denote the person negative report. In this, probability of person getting a positive report is 0.01. Probability of E2, all other negative automatically 1.01. Sorry, 0.99. Now arbitrary event, second type. Let A denote arbitrary event. Incorrect report. That is, okay. Person tested gets an incorrect report. That incorrect report of that person may be from positive report or negative report. Then P of A given E1. What is the meaning? From positive reports that the person gets incorrect report. Okay. How much it is given? 12%. So nothing but 0.12. And P of A given E2. From negative reports, how many persons tested gets incorrect report? That is 15%. Nothing but 0.15. Now the question, probability that the person gets incorrect report. Person gets incorrect report, it is A only. So therefore, required probability is P of A only. If the say in the same question gets an incorrect report, came from positive or that the reports from negative, that means inverse event Bayes theorem. Here it is not asked like that. That is rule of total probability. So probability of E1, probability of positive report into probability that the positive report is incorrect. That is A given E1 or means adding probability of negative report, that is E2 into incorrect report from negative report, that is A given E2. So this simplifies to 0.01 into 0.12 plus 0.99 into 0.15. Please check. Approximately 0.1497. Please check. So this is called rule of total probability using when there is a sentence came from already from the positive reports or from some event, that is called inverse event probability Bayes theorem. Otherwise, rule of total probability. Rule of total probability. Okay, now we'll do practice session questions. Yes. Number 1, a coin is tossed thrice. Let X be the event that head occurs in each of the first 2 tosses. Okay. Y be the event that a tail occurs on the 3rd toss. Let Z be the event that 2 tails occur in 3 tosses. Based on the above information, which one of the following statements is true? A, B, C, D given. So let us convert into roster form. X is equal to 3 coins. So mod S, not required to write, total 2 cube 8. Head occurs in each of the first 2 tosses. H, H, T. H, 3rd toss may be tail or head. That doesn't matter. So first 2 tosses heads are there or not. If first 2 tosses only heads means automatically HHT outcome only will come under that X event. Why? Tail occurs on the 3rd toss. So that is H, H, T. H, T, T. T, H, T. T, T, T. So 3rd toss tail is there or not? Like that. Z. Even the two tails occur in three tosses. That is any two tosses, two tails. So T, T, H, H, T, 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 H, T. Any other thing? Three favorable outcomes. Mod S, total sample space outcomes 2 cube is equal to 8. Please check. Now, according to the options, events dependent, event independent, first priority is C. X intersection Y. X intersection Y, how much? H, H, T only. Y intersection Z, how much? T, H, T. H, T, T. Only two outcomes. And Z intersection X, how much? So no events. That is, no outcome is common. 5. Am I correct or not? So, probability of X, 2 favorable outcomes out of 8, 2 by 8. Probability of event Y, 4 favorable outcomes out of total outcomes 8. Probability of event Z, 3 favorable outcomes out of 8. Now, probability of X intersection Y, only 1 favorable outcome out of total 8. Probability of Y intersection Z, 2 favorable outcomes out of total 8 comes. Probability of Z intersection, no favorable outcome, that is 0. So, this is P of X into P of Y. How much? Is nothing but P of X into P of Y. So, X and Y are independent. So, he is asking which of the following statement is true. This is wrong in the given. Now, what is P of Y? 4 by 8. P of Z 3 by 8. So, it is, you will be getting 3 by 16, which is not equal to 3 by 16, which is nothing but P of Y into P of Z. That means probability of Y intersection Z is not equal to P of Y into P of Z. So, which implies Y comma Z are not independent. Here, X comma Y are independent. So, option A wrong. Y and Z are not independent. That means Y comma Z are dependent. So, option B correct. Y and Z independent, not independent, we got X and Z. So, this is P of X into P of Z. How much? 3 by 32, which is nothing but P of X into P of Z. So, X, Z are not independent. So, this is also wrong. Okay. So, what is your answer finally? Y and Z are not independent, that is dependent. Option B answer. Please do second one. In a factory, two machines M1 and M2 manufacture 60% and 40% of the auto components respectively. Okay, that is machine M1 60%, machine M2 corresponds to 40% components. Out of the total production, 2% of M1, 3% of M2 are defective. This is arbitrary event A defective. E1 means machine 1 components, event E2, machine 2 components, 60%, 40%. If a randomly drawn auto component from the combined lot is found defective, the question related to defective, but the probability that it was means already happened, past tense, that is going back, that is inverse event. So the question related to machine M2 after the drawn component is defective. So here, using Bayes theorem, let E1 denotes M1 manufacture components, E2 denote machine 2 manufacture components. From this, the information from the question, P of E1 60% and P of E2 40%. Now arbitrary event, let A denote component found to be defective. Defective means bad, non-defective means good. From this, probability of A given E1. What does it mean? A given E1 means from the machine 1 total components, how many defective? Probability of getting a defective component. So that is given 2%. And probability of A given E2. From the machine 2 components, probability that the defective is 3%. Very less. 2%, 3%. Now the question related to defective component is already happened. Event A happened, but the question is came by M2 machine. That is inverse event probability. Bayes theorem. Required probability is P of E2 given A is equal to probability of numerator event E2 into probability of inverse event A given E2 whole divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 using Bayes theorem. So probability of E2 is 0.4. Probability of A given E2 is 3%, that is 0.03. Whole divided by probability of E1 is 0.6. Probability of A given E2 is 0.02 plus 0.4. You can write decimal fraction or original fractions. For 60 by 100, 6 by 10, 40 by 100, 4 by 10, 2%, 2 by 100, 3%, 3 by 100, 0.03. So this simplifies to 0.5. Please check accordingly. Option C. This is using Bayes theorem. So I hope that everyone following, please subscribe the channel. Okay. GATEFORUM providing various courses just like online classes, live based classes, daily classes, and refresher course. Refresher course concept part with each definition, subtopic, examples provided, and 2010 to 20 gate questions explanations. and test series. 3 types of test series, chapter wise and topic wise, and final length of, that is target full length test, that is according to gate pattern, that is called target test. Okay, so similarly in the upcoming weeks we'll have some other topics on engineering mathematics and followed by covering technical subjects. Okay, for getting more videos please subscribe the channel. Now next question. 10% of the population in a town is HIV plus. A new diagnostic kit for HIV detection is available. This kit correctly identifies HIV plus individuals 95% of the time and HIV minus individuals 89% of the time. A particular patient is tested using this kit and is found to be positive. So please underline patient tested found to be positive. So 10% HIV plus, automatically 90% HIV minus. So correctly identifies HIV plus 95% and correctly identify HIV minus 89%. The probability that an individual is actually positive, that is going back to the positive cases, that is inverse event probability. So very, very important, this probability, this problem. Here total population is not given. Let total population, you can say 100,000, anything, be 100 people. Okay, so implies HIV plus is equal to, that is patients or people, 10 HIV negative patients is equal to 90. Now I can give a table. So kit, the question related to tested, kit tested. So here sometimes correctly, some other patients wrong. Say recently corona also, in some situations negative report, even they are having corona. Recently happened so many cases. Okay, here the two types, HIV plus, HIV minus. So the kit tested correctly that HIV individuals, that is patients, is how much? 95%. 95% means 0.95. Automatically wrong means remaining 5%. Total HIV patients, that is 0.05. HIV negative correctly, that is given 89%, that is 0.89. Remaining 11%, HIV negative is wrong, that is 0.11. Take care. So from this probability of HIV plus, see 10% of the population in a town is HIV plus is given 10%, that is 0.1, implies probability of remaining HIV minus, that is population people having negative HIV is 90%. 1 minus 10%, 90% means 0.9. Take care. So here, and what exactly other things given, the probability that an individual is actually positive means I can write directly required probability. Therefore, I can't give here even E to E, even event A, just like in previous Bayes theorems. Take care, this problem is very, very important. Required probability is probability of HIV plus, that is came from that an individual is actually positive. HIV plus means actually positive. HIV negative means actually negative. Given that test here, patient tested and found to be positive. Okay. Test. See, a particular patient is tested using the kit found to be, before that, a diagnostic kit HIV detection is available. This kit correctly. That is test suffix correct. Okay. This is the required probability. So here, probability of numerator event HIV plus into probability of inverse event test correct from HIV actually positive patients whole divided by total cases HIV plus into probability of test correct given that HIV plus. So this is the case where I am putting tick by blue color. Please observe. This is favorable cases and this is favorable cases. HIV negative wrong means opposite language. This is positive. Okay, tested found to be positive. Okay, so this is probability of HIV negative into probability of test wrong. Test wrong, test giving wrong from HIV negative patients. So HIV negative patients test given wrong means automatically this is positive. So this is HIV plus how much? 0.1. Test correct HIV plus 0.95 whole divided by 0.1 into 0.95 plus HIV negative is 0.9 into test wrong HIV. Sorry, this is HIV negative. It's not power plus. Kindly excuse me. This symbol is negative. Negative and wrong automatically becomes positive. So 0. That is here 0.11. This is the required value. 0.1 into 0.95, 0.1 into 0.95 plus 0.9 into 0.11. This is approximately 0.489. Please check. So this is the answer 0.489. Now the last example in this fourth one, in a certain village, 5% of the men and 2% of the women are taller than 1.8 m. M means meters. Furthermore, 60% of the people are men. Automatically 40% remaining are women. Then the probability that a person is selected at random and is taller than 1 m. So this is the question. probability percent taller than 1.8. Okay. So third solution here I am doing. Space is sufficient. Let E1 men percent E2. Simple working. Because working is not important in while doing these problems, for understanding purpose only. In questions, while doing these problems, just they depend on numeric question, numeric answer or multiple choice question. E2, woman person. From this information given, P of E1, how much? 5%. And P of E2, 2%. Now arbitrary event. Let A denote person selected, comma, taller than 1.8 meters. From this, probability of A given even. From men person, probability that a men person from the total men person taller than 1.8 meters is, kindly excuse me, here 5% given, men person taller than 1.8. 2% is given, women person taller than 1.8. So I have considered here reverse way. See, here given, furthermore 60% of the people are men. Remaining 1 minus 60% is equal to 40%. In the men persons, the probability taller than 1.8 is given, that is 5%. And probability of A given E2, that is from woman person taller than 1.8, that is 2%. Therefore, required probability is P of A, that is probability that a person is selected taller than 1.8. Taller than 1.8, we denoted the event A using rule of total probability, P of E1, probability of men person selected. After selecting men person, the person more than 1.8 meter taller, that is taller than 1.8 meter, that is A given E1, or selecting woman person and then probability that woman person taller than 1.8 meters is nothing but multiplied by probability of A given E2. Now this is 60%, that is 0.6 into 5%, 0.05 plus 40%, 0.4 into 2%, 0.02. Approximately, please find it. I think 0.038. This is 0.038. Accordingly, option B is the answer. Hope that everyone understood. Good following, good going. So now I'm going to give 5 minutes a few discussion on random variables. So far we have discussed probability on non-numeric objects, that is blue ball, red ball, head, tail, king card, queen card. These are all non-numeric things. Now these are numeric things. What is the purpose for that we are studying random variables? A simple live example I am telling you. A dice is thrown 20 times. What is the probability of getting 2 dots, that is number 2, on the top face of the die at least 5 times? At most 3 times, exactly 10 times. These questions, if you do by previous classes methods, how much time taking? If it is time taking, that is, will you feel easy? Otherwise, it is very tough task. Otherwise, we can't apply the previous topics. These are the things happened. So when you are playing large number of times, then convert into numeric things. That is the purpose we are studying random variables. This is one example. Now, another example. A company manufactures cars daily, out of which 1% is defective. On an average, 1% of the defective cars. So if I purchase 2 cars from the company on a day, what is the probability that the 2 cars are bad, defective cars, or only one defective car, or none of the cars is defective? Such problems can you do by the previous topics method? This topic is helpful, numeric things. Okay, so you know the meaning of a function. 9th, 10th class, 12th standard, 11th standard. There are 2 sets, A and B. A is domain, B is codomain. Every element of the domain A is associated to a unique element in the second set B. B is codomain. Such associations is called function from A to B. Here random variable is also a function. Suppose that to each outcome of a sample space S, you know sample space S, outcomes you know, we assign a real number. That is, for every outcome, we put a number depending on the situation of the problem. That number is denoted by small x. Some people denote by small y. We then have a function defined on S. This function is called random variable, short form RV, or more precisely a random function also. Some people call random function. Usually denoted by capital letters, upper class letters, capital X or capital Y or capital Z, etc. The values for capital X, because numeric, capital X is now a number. Such numbers is called outcomes, numeric outcomes denoted by small x1, small x2, small x3. Capital Y having values denoted by small y1, small y2, etc. So this is the symbolic notation for random variable. X is a function from S to R. S is domain, R is codomain, R is set of real numbers, S is sample space of the random experiment, X is function. Here it is of 2 types, because random variable means numbers generally 2 types. Finite numbers. What is the meaning of finite numbers? If I have 4 numbers, 1, 2, 3, 4 given below, these are countable one after one, correct or not? But there is an end. 100 numbers, there is end. That is called finite numbers. If I say 1, 2, 3, one after one reading, 4, etc. If I do not say the last number, endless number, this is infinite numbers, but it is countable. You are counting one after one, numbers, natural numbers, whole numbers. Okay, countable infinite numbers. Such numbers are called discrete random variable. Can you tell every number, all numbers between -1 and 1? Can you read all numbers between -1 and 1? All rational numbers, irrational numbers? You can't arrange one after one, correct or not? That is called uncountably or non-countably infinite numbers. Between -1 and 1, you can't read one after one. That is uncountable. Infinite numbers means between 2 small numbers, there lie infinitely many numbers. So such numbers are called continuous random variable. Is also called non-discrete random variable. This is the example. Discrete random variable examples. Continuous random variable means intervals, open intervals, closed intervals, etc. All real numbers is a continuous random variable. Now, so for each type of random variable is now a numeric outcome. For every outcome, you have a probability we studied in the previous sessions. Similarly here also. Because of 2 types of random variables, you have 2 different notations. That is to overcome the concept, some others. That means in some textbooks, they have given 2 different notations. Each notation for each variable. P of X. Some people didn't by P of capital X is equal to small x, or P capital X suffix capital X of small x. Here capital X is a random variable. That values are denoted by small x, small x1, small x2, etc. Is called the probability mass function. But some people simply called probability function. To overcome the definition between 2 types, we are using probability mass function for discrete random variable. whose notation is P of X. X is a value of X. When you are saying something is a probability, what are the conditions? Basic conditions. Probability of every outcome is always greater than or equal to 0. What is 0 means? Probability that the event doesn't happen. That is probability that an event, that the sun rises in the west. Impossible event probability is 0. Okay. Now summation taken over X, P of X is equal to 1 means sum of all probabilities of the random variable here outcome is small x. Sum of all probabilities equal to 1, where sum is taken over all possible values of X. So here I will do one example. How to go through this question. Please write, all of you. The question is, the probability function, fn means function of a discrete random variable, RV stands for random variable short form, is given by P of X is equal to, sometimes some people denote by capital X. Don't worry about the notation. Lambda times half raised to X, where X takes the range values of X, taking the values of X 1, 2, 3, so on. That means countably infinite. Then the value of the constant lambda is equal to dash. So, solution. Since P of X is probability, imply summation taken or all values 1, 2, 3, so on infinity, P of X is equal to 1, which implies P of X is equal to 1 plus P of X is equal to 2. You can write capital X or small x, don't worry, is equal to 1. In all these, lambda is common, take out half plus putting X is equal to 1, 2, 3 respectively. After taking lambda and summing means adding whole square, half, whole cube, plus so on. All this simplifies to 1 given. So this is lambda 1 by 2 is also common, take out, and then 1 plus 1 by 2 plus 1 by 2 whole square plus so on is equal to 1. So this is a geometric series which is from 9th, 10th class, 12th standard, intermediate, etc. Or Maclaurin series from calculus. We are going to discuss in the next sessions these type of problems. 1 plus x square, etc. is equal to 1 minus x whole to the power minus 1 if that common ratio lies between minus 1 and 1. This is from childhood class we studied. Geometric series. So in place of x we have 1 by 2 lambda by 2 into 1 minus 1 by 2 whole power minus 1 is equal to 1. 1 minus 1 by 2, 1 by 2. 1 by 2 inverse negative, that means reciprocal. So lambda by 2, 1 by 2 inverse is 2. So this simplifies to finally 1. So last, this is the definition. F of x is the probability density function, short form PDF, of a continuous random variable. For a discrete random variable x, the short form PMF, that is given by P of x, which satisfy probability of every outcome is greater than or equal to 0. In continuous, we cannot count, that is uncountable. That's why operator is integration. Integration taken over all x, f of x dx equal to 1, where integration is taken over all possible values of x. This is another example of discrete random variable, the probability distribution. Okay. Not required to explain, easy to understand. So just one example. It will take 1 or 2 minutes. The question is, a random variable RV has probability density function f of x is equal to a times e to the power minus mod x minus 10. Then a is equal to dash. Solution. Here x value is not mentioned. That is default case taken to be all real numbers minus infinity to infinity. X takes minus infinity to plus infinity. Since f of x is probability density function, short form PDF, implies integration taken over all x f of x dx equal to 1. So which implies integration minus infinity to infinity a times e to the power minus mod x minus 10 dx is equal to 1. Please remember, absolute value of a real number is denoted by mod x. This is defined as plus x if x greater than 0, minus x if x less than 0, 0 if x equal 0. Modulus of a non-zero number is always positive. Modulus of a zero number is 0. So this x minus 10, where it becomes 0 at x is equal to 10. According to the splitting limits, a to b, integral a to b can be written as a to c plus c to b, that is minus infinity to 10. Take out a is a multiplication constant, e to the power minus mod x minus 10 dx plus a times 10 to infinity e to the power minus mod x minus 10 dx is equal to 1. Okay, since integral a to b can be written as integral a to c plus integral c to b, provided a less than c less than b. Between the limits, a is lower limit, b is upper limit, take any number, you can write like this. Properties of definite integral, which we studied from 12th, 11th standard. So minus infinity to 10, if you take any number, this quantity is negative. So negative into negative positive, so this becomes mod x is equal to minus x if x is already negative. Okay, so modulus is always a positive quantity. Minus infinity to 10 e to the power, simply you will be getting x minus 10 dx. Between 10 to infinity, any number if you take, this will be positive. So mod x is equal to plus x if x is positive. That means here x minus 10 is positive. You will be getting a times 10 to infinity e to the power 10 minus x dx is equal to 1. This implies a times e to the power x integration e to the power x minus 10 dividing by x coefficient 1. That is minus infinity to 10. Similarly, plus a e to the power 10 minus x integration is e to the power 10 minus x divided by minus 1 x coefficient. This is 10 to infinity is equal to 1. Since integral e to the power ax, a is a constant, negative or positive, whatever it will be, whatever it may be, e power ax by a, whatever it may be. Okay, so now remember, e power minus infinity is 0, but e power plus infinity is equal to infinity. So this simplifies to a into e power 10 minus 10 e power 0 1 minus e power minus infinity 0 plus a into e power minus infinity 0 dividing by minus 1 minus e power 10 minus 10 e power 0 1. So I can write 1 minus 0 reverse way is equal to 1. So this simplifies to 2a is equal to 1, implies a is equal to 0.5 or half, depending on the options or numeric quotient. So attending the sessions, thank you for everyone. I hope that everyone understood. In the upcoming weeks, we will have some other topics on engineering mathematics. Please subscribe the channel. And again, GATEFORUM offering many courses, live session, online classes, e-gate classes, etc. And refresher course is also available. So thank you. Bye-bye.